Okay, so this is the first video that you're going to have to watch and take notes on at home. It's over surface area, and the surface area of a three-dimensional figure is the sum of the areas of the faces, especially if it has plane faces. It makes it really easy for us just to break it down. So if we collapse the figure into its net, the surface area is the area of the net. So if we have a box here, then the area, if we break it down into the net, the surface area is all of these areas, and we just add it together. So if we look at this one, we have a square pyramid. The base is a square, so we name it by its base, and then it's a pyramid because it comes to a point or a vertex opposite the base. And we want to find the surface area. So basically what we have is we have a square, and then coming off of each square, we're going to have a triangle. So if we drew a rough sketch, this is what we're looking at. And if we pull out our square and just look at the square, then each side of that square is 13.2. And then if we look at the triangle separately, and if I draw the triangle up here, then the base of the triangle is 13.2 because every side of that square is the same length, and then our height is 22.4. So basically I'm going to find the area of my square, and then I'm going to add to it the area of my triangle 3 times. So plus the area of my triangle, plus the area of my triangle, plus the area of the triangle, and then the fourth triangle, because I have 1, 2, 3, 4 of them. So to find the area of the square, I'm just going to do 13.2 times 13.2, and that'll give me the area of the square. And then I've got 4 of my areas of a triangle, so there's going to be 4 of them. So I'll just multiply by 4, and the area of my triangle is base times height divided by 2, so we get base, which is 13.2, times the height, which is 22.4, divided by 2. Here's the base of my triangle, here's the height of my triangle, so 13.2 times 22.4, and I divide that by 2 because that's how I find the area of the triangle. And when I add all of that together in my calculator, I get 766 centimeters squared, and it's centimeters squared because it's area. And that should have an E at the end. Example, much better. Okay, so cylinders and spheres, these are the objects that have curved surfaces. Sometimes we call them curved surface solids. And we use a formula to calculate their surface area. So the cylinder, the surface area of a cylinder is going to be 2 pi RH, that's our curved surface, plus the 2 pi r squared, and it's 2 pi r squared because we're taking the circle of pi r squared and we're multiplying it by 2 because we have 2. The sphere, the formula is 4 pi r squared. And then a cone, we have our curved surface, and then we have our circular base. So the pi r squared is our circular base. And then pi r L, and L is a slant height. So it's not the height because a height has to reach a 90-degree angle. So this would be my height because it intersects my base at a 90-degree angle. This is my slant height. It's the height of my slant, and that's what we call L. So here are 3 examples. They want us to find the surface area to 1 decimal place. So here we have a cylinder, and we've said that the area, the surface area of a cylinder from our chart before, if we go back, is 2 pi RH plus 2 pi r squared. So we're going to have 2 pi RH plus 2 pi r squared. So that is our surface area. Except it's hollow. So the top and the bottom are hollow, so that means that there's nothing there. So we can take this off because there's no top or bottom, it's hollow. So all we're looking for then is the surface area of the curved surface. So we get 2 times pi times the radius, which is 6, times the height, which is 15. And when we plug that into our calculator, we get 565.5 centimeters squared. Use the pi button, not 3.14. And again, we took off the ends or the area of our 2 circles because they don't exist, because it tells us it's hollow on the top and the bottom. So then our cylinder, the formula for the surface area is 4 pi r squared. So basically we have 4 times pi, and then r is 8 squared, so that's 64. And when we plug that into our calculator, we get 804.2 centimeters squared. Now all of these values that I'm giving plugged into the calculator, you should be, there's an E missing there too. You should be plugging those actually into a calculator so you can see if you're getting the right answer, because if you're not, then you need to know that there's an issue with the way you're plugging it in. And then the cone, our area is pi r L for the slant height plus pi r squared, which is our base. So we get pi, our slant height is right here, so that's 12. And then times the radius is 5. And then plus pi times r squared. Let me erase that and make it to where we can fit it all in there. All right, let's try this again. So we get pi times the radius of 5 times 12 plus pi times 5 squared, because that's my radius. And when I plug that into my calculator, I get 267.0 centimeters squared. And I added the 0.0 because it asks me to find it to 1 decimal place. And so I need to add in that 0.0. Then our last example for this PowerPoint, I left off the E again, we have the length of a hollow pipe. So again, the length, it's hollow. So if we draw this pipe, we have this hollow pipe. Okay, and the length is 3 times the radius, so we'll say that the radius is r, and then the length, or the height, is 3r, because it's 3 times the radius. So if the radius is r, then the height is 3r. So its outer surface area, our formula again is 2 pi rh, because it's hollow, so we don't have the ends, so there's no plus pi r squared. So 2 pi, and then we have r, and then our height is 3r. So if we combine that, then we get 6 pi r squared. Because 3 times 2, I can combine those. 3 times 2 gives me 6, and then I have pi, and then r times r is r squared. So my expression for the outer surface area is 6 pi r squared. Then it says if its outer surface area is 301.6 to find its radius. So that means that if this is my surface area, then I'm going to plug in 301.6, and that's going to be equal to 6 pi r squared, because that's the formula for my surface area. So then I have to divide both sides by 6 pi to get r squared by itself. So I end up with r squared is equal to 301.6 divided by 6 pi. And then to find r, I simply take the square root of both sides. And when I put that into my calculator and take the square root of both sides, I get that r is approximately 4 meters, 4.0 meters. That's the end of this PowerPoint. Make sure you've taken notes on them. Bring them to class tomorrow because I plan on grading them.